Whether you realize it or not, science is part of your everyday lives. So the first thing we need to look at is what is science and how to think like a scientist. So the goals of science is to understand the hows and whys of the world. Scientists are always curious about the world around them. They look to answer their questions through their observations, through the things that they see and hear and smell and touch. And they use this information to draw logical conclusions. So the term science is actually a Latin word, and it comes from the words, or it literally means having or to have knowledge. So today's modern scientists have defined science as a way of learning about the natural world that is based on logic and evidence. So when people think about science, sometimes they have these ideas that are actually incorrect, but they sound good. So we actually call them misconceptions. So these are really false ideas about science. So one of the misconceptions about science is that it is simply a collection of facts. So science doesn't claim to know everything or have an answer for everything. And it's constantly evolving. And so we can call that misconception number 2, is that some people think that science is complete and absolute and unchanging. So science is really incomplete. Scientists don't know everything. And what we do know, we can't say for 100% certainty that it's 100% true. And so as soon as a scientist were to find something that contradicted a fact, science would have to change. And so the third thing is that science proves ideas. Science doesn't prove anything. Rather, we use the word support. Scientific evidence supports an idea or a concept. It doesn't actually prove it. Scientists are very adamant that nothing can be proven by science. If things were proven by science, it would make them absolute, that they couldn't ever change or they couldn't ever evolve. And so scientists strive to find ways or new ideas to help science evolve. So one of the ways scientists think is called induction or inductive reasoning. And this is when you draw general conclusions from many individual observations. So let's pretend you don't know anything about gravity. You don't know it exists, you don't know what it is, you don't know what results because of gravity, you know nothing about gravity. But you make these 3 observations here. A dropped book will crash to the floor, a pencil on the edge of the desk will roll to the floor, and a ball thrown, a football, volleyball, dodgeball, whatever, will eventually fall back. So based on these 3 observations, you can make the conclusion that all objects fall to the ground. That's great and dandy until you make this 4th observation where a helium-filled balloon rises unless it's held onto. This new observation now contradicts your first conclusion. So instead of throwing out this first conclusion, what a scientist would do is observe more helium balloons and try to find other objects that tend to fall up instead of down. Doing this allows you to become to have a better understanding based on all the observations. And so this allows you to come up with new conclusions that could maybe be objects heavier than air fall to the ground, but objects lighter than air do not. So these 4 examples, 1, 2, 3, and 4, are all used for inductive reasoning or induction because you use the observations, many observations, to make a general conclusion. So science, I said on the first slide, strives to advance. So science advances every time we find new evidence. Is usually used to improve earlier ideas rather than replace them. So much like on this slide, where this 4th observation gave us new evidence, instead of completely throwing out this conclusion, we revisited it, made more observations, and used the first conclusion as part of our second conclusion. So this allows scientists to gradually refine the ideas and increase the understanding of the world. Sometimes science advances in big leaps, especially like when Albert Einstein started looking into gravity. Einstein believed that gravity is a dent in the fabric of space and time. Super complex ideas there. Different conclusions can be drawn from the same observations. And you know this is true in your daily life, that 2 people can interpret the same situation in 2 different ways. Or in science, we had observers watching the sun move across the sky. And so back in those times, we didn't have the technology to learn about the sun as we do now. So the big question back in the day was, does the sun orbit around the earth, or does the earth orbit around the sun? Both were valid ideas until we had better technology or stronger microscopes, and you could make new observations to better write a conclusion. So this first picture here is with the earth in the center, and then the second would be your sun in the center. Both valid ideas, but only one of them turned out to be correct. This leads us to scientific theories. All these observations, all these conclusions end up making what we call scientific theory. And this is a broad explanation explaining why something happens. It's widely accepted because it is supported by a great deal of evidence. Notice the word supported. We didn't use the word proved. It's supported by a great deal of evidence. So an example here is the kinetic theory of matter. This theory explains why there are differences in particle speeds. So you should know by now that there are 3 states of matter. We have solids, liquids, and gases. And all of those solids, liquids, and gases are made up of tiny atoms and molecules. And this kinetic theory of matter says that those tiny particles are always moving. However, they move at different speeds depending on what state of matter. So if you look at this diagram, here the solid particles, they don't move very much. They're more of a vibrating kind of movement, where liquid molecules have a tendency to flow, and gas molecules, they are zooming. They go crazy. They are all over the place. They're just flying fast. And so this kinetic theory of matter explains why those different speeds exist, and we'll talk about those in a few chapters from now. Scientific laws is a statement describing what always happens under certain conditions in nature. It answers the question how. So, for example, Newton's law of gravity describes how all objects attract each other. It states that the force of attraction is greater for objects that are closer together or have more mass. It does not explain why those objects are attracted to one another. That's where Einstein's theory comes in. His theory explains why. So, a little memory trick for you to remember the difference between laws, scientific laws, and scientific theories is with law, notice how there's a W, and laws describe what is happening. Scientific theories, theory ends in a Y, and they explain why something happens. So hopefully those help you remember your vocabulary words for your vocab quiz. So science has been around forever, pretty much. And so modern science has roots that go back thousands and thousands of years. So new ideas are often not accepted at first because they conflict accepted views of the world. So Copernicus, he had the idea that the sun was the center of the solar system. It was rejected at first because people firmly believed that Earth was the center of the solar system and that the sun revolved around that. And so even though Copernicus was right, his idea was rejected for a long time because people just wouldn't accept it as fact and as truth. So here we have some science and the discoveries, scientists and their discoveries. You will be responsible for this information on your tests and your quiz. So in the Mesopotamian calendar, there were several ancient civilizations. They studied astronomy. They recorded their observations of the movement of stars, sun, and moon. And we still use a calendar developed by the Mesopotamians about 5,500 years ago. And it's based on the moon cycles, which is loosely what our current calendar is based off of. About 600 BC's, Thales was an ancient Greek philosopher, and he proposed that natural events such as lightning and earthquakes have natural causes. Up until then, people blamed such events on gods or other supernatural causes. Thales has been called the father of science for his ideas about the natural world. 350 BC, Aristotle, he might be one you may have heard of once upon a time. He was a Greek philosopher and argued that truth about the natural world can be discovered through observation and induction. This idea was called empiricism. Aristotle's empiricism laid the foundation for the methods of modern science, as you can see with the observation and induction. 400 AD to 1000 AD, the early Chinese, they developed a seismograph. If you remember from your 8th grade science, seismographs record earthquakes. So when Europe went through the Dark Ages, European science withered. However, the other places, science still flourished. In North Africa, the scientist Alhazen studied light. He used experiments to test competing theories about light. And then in China, scientists invited compasses. They also invited the seismograph to measure earthquakes, and they studied astronomy. So from the 1500s to the late 1600s, we had Galileo. This is when the scientific revolution occurred in Europe. This was the beginning of modern Western science. Many scientific advances were made during this time. Here's your Copernicus again. He proposed that the sun was the center of the solar system. Galileo improved the telescope and made important discoveries in astronomy. He was the one discovering evidence to support Copernicus. And then we had Newton proposing the laws of gravity. Jump to 2001. Many scientists around the world work together to complete genetic sequence of human chromosomes. This will help scientists understand, perhaps someday cure genetic diseases. And women have not always had a place in science, as have people of color. So we want to touch on these scientists too. So one of maybe the more famous women in science was Marie Curie. She was the first woman to win the Nobel Prize. She won it in 1903 in physics for the discovery of radiation. And she won the 1911 Nobel Prize in chemistry for discovering the elements radium and polonium. Fun/disturbing fact, she, because of her research, developed radiation poisoning, and it eventually killed her. Lise Meitner was one of the scientists who discovered nuclear fusion. This is how we create energy in nuclear power plants. Irene Jolie Curie was a daughter of Marie Curie, who won the 1935 Nobel Prize in Chemistry with her husband for the synthesis or making of new radioactive elements. So if you look at the periodic tables, the elements kind of on the bottom right-hand side are newly synthesized or newly created. Maria Mayer was a co-winner of the 1963 Nobel Prize for the discoveries of the structure of the nucleus of the atom. Ada E. Jonas was a co-winner of the 2009 Nobel Prize in Chemistry, making important discoveries about ribosomes in cells, and especially because this is where proteins are made. Shirley Ann Jackson earned a doctoral degree in physics and became the chair of the U.S. Nuclear Regulatory Commission. And then we have Ellen Okora, I don't know how to say her last name, in 1958, and she's still alive today. She's an inventor, research scientist, and a NASA astronaut. She's been up to space many, many times. So, to recap, science is always changing. Science is always changing. And it's changing based on new evidence that scientists find. And so we need science to change, and we need it to advance. So like in the medical field, if we weren't making new observations and new discoveries and finding new evidence, our medical field would never advance. People would continually die from the same things. And so the idea that science is always changing is key.